All right, so our question was, how does fractional distillation work? Each group typed in their answer. Then you had a choice to vote on 5 different answers. And this little red bar shows selection. So our winning one was letter B. The specific components of a mixture are boiled into a vapor, and as the vapors ascend through an apparatus, the different components condense into liquid form at different levels based on their condensation temperature. So what do we think about some of the terminology used in there? Good, appropriate, not appropriate? So you guys got to be careful. If you start throwing a word out there and it's not used correctly, I will hold you accountable. So are there any words here that maybe we could change a little bit? Do you boil something into a vapor? What does it mean to boil something? You guys have your iPads, Google it. If you boil something, isn't it implied that you create a vapor? Yes? Of course. So, what kind of a mixture, first of all, do we need to have? What kind of mixture do we need to have in order to do this? A liquid mixture. And what kind of liquid mixture are we talking about in this particular case? What are we talking about in this unit? Petroleum, crude oil, right? And it's really not what we would think of as like Gatorade or water, but it's a viscous goo. But the specific components of a liquid mixture are either boiled or are vaporized. That's sort of redundant to say boiled into a vapor. See my wordsmithing? Yes? I'm being very nitpicky here, but that allows us to do this. Are boiled, and as the vapors ascend, nice literary term there, through an apparatus. What does that mean? Is it a straw? Is it... I don't know. So do we like apparatus, or should we replace... If we're going to say something, then we might as well be more specific. Yes? Brian? Ah, very good. Through a distillation tower, the different components condense into liquid form at different levels based on their condensation temperature. Yes? Now, could I say boiling point here? Or boiling temperature? This is a common misconception. Is boiling and condensing, when do they occur? Same temperatures, different temperatures? Awkward silence? So, I have a continuum. Low temperature, high temperature. I have a block of ice, and I'm heating it. What happens to the ice as I heat it? At some point it does what?
Turns to a liquid.
It melts, right? I continue to heat it. Now it's a liquid. And at some point it does what? It evaporates. And it forms a gas. Now I take this gas. I cool it down. At some point it does what? Turns to liquid. And what's that called? Condenses. Now it's a liquid. I continue to cool it down. And at some point it does what? Freezes. So you may never have thought of the fact that melting and freezing occur at the same temperature. Evaporation and condensation occur at the same temperature. It's just which way you're going. Make sense? So, what do we think about doing this instead of pass the marker? Keep Chuck? Like it better than pass the marker? At least it's not a log jam up here. The only issue is we are limited to the number of responses, but I think if 6 is good if we work collaboratively, yes? Cool. All right, Nikki.